Today I will discuss the basic concepts of genetic algorithms. The topics are Introduction to Genetic Algorithms, Genetic Algorithm Operators and Parameters, Advantages of Genetic Algorithm. Now, what are genetic algorithms? Genetic algorithm was first proposed by Holland in 1975. Actually, this is one popular optimization technique and it is based on Darwin's principle of natural selection. What happens in case of genetic algorithm? We starts with a set of randomly generated initial solution. This is called initial population. In a population, there are number of solutions and we need to evaluate all of the solutions. That is, we need to calculate the fitness value of each of the solution. Then the process is iterated. A pair of solution is chosen and using the pair of the solution we perform crossover and mutation, and this results in two new chromosome or two new solution. Then in this way, from a initial population, one new population is created, and again the fitness is evaluated for each of the solution. Now in case of genetic algorithm, we term each of the solution as a separate chromosome. A set of solution is called a population. So basically the process is that we start with a randomly generated initial population, then we evaluate the fitness of each solution or each chromosome, then until we get the feasible solution, the selection is done for crossover, then on the resultant chromosome mutation is applied and the process continues. Now here is the simple pseudocode for genetic algorithm. Simple genetic algorithm, we start with initial population, then we calculate fitness function. While the fitness value is not equal to optimal value, then the selection and crossover is done, then mutation is applied on the resultant chromosome, then the process is repeated. Now the GA operators and the parameters. First we need to know how the encoding is done, because when we apply genetic algorithm to our problem, we need to represent our solution in the form of a chromosome. Okay, a chromosome is a string that conveys the necessary information. Encoding method, one popular method is binary encoding. In this case, the solution, that is each chromosome, is represented in the form of a binary string. All these values are either 0 or 1. Here is two examples of chromosome A and chromosome B. These are two different solutions. Another encoding method is permutation encoding. This is useful in case of some problem where like TSP. In TSP we know that each cities are numbered from 1 to n, in this case 1 to 9, and we need to visit each city exactly once and then return to the starting position. So in this case there will be no repetition of cities except the first one. So this is called permutation encoding. Now how the selection is done in genetic algorithm? The basic method is called Rowlett wheel selection. The objective is that higher the fitness of a chromosome, higher is the chance of selection. The technique is that we calculate the fitness of each of the chromosomes, and then we draw a graph. The graph looks like this. In this case, we can see there are 4 chromosomes, 1, 2, 3, 4. The fitness of the 4th chromosome is the highest, and the fitness of the first chromosome is 14.4. Okay, then the fitness of the second chromosome is highest. Now we have calculated the fitness of each of the chromosome, and from this wheel we can see that the second chromosome has the highest fitness, which is 49.2%. Now if we spin this wheel, the chance of selection of this portion is higher than any other chromosome. So if we use this Rowlett wheel method, the chromosome with the highest fitness function has the highest chance of get selected for the crossover. So the concept is that higher the fitness, higher the chance for selection. Now what is crossover? Crossover is the process in which 2 chromosomes combine their genetic material, that is the bits, to produce a new offspring which possesses both their characteristics. Now this will be clear if we consider the example of single point crossover. Single point crossover means there are 2 chromosomes, string 1 and string 2, and we have chosen a single point randomly. The crossover will take place at this particular point. So by crossover, these 2 chromosomes, chromosome 1 and 2, will interchange their parts. Now you can see that this part is added with this portion of the second chromosome. Now the result is this. Similarly, with this part, this portion of the first chromosome is added. So the result is this one. So after the single point crossover, the result of chromosome 1 and 2 is these 2 new chromosomes. Another example, another example of single point crossover, chromosome 1 and 2. Crossover is applied after this point and information is exchanged. After this bit, this is added. This is the first child or the offspring 1, and this is offspring 2. Now similarly, like single point crossover, 2 point crossover or multi-point crossover is possible. In this case we can see that 2 points are chosen, this and this, for the crossover. These are the parent chromosome and these are the offsprings. Here are a few points regarding crossover. Crossover between 2 good solutions may not always yield a better or as good a solution. But since the parents are good, probability of the child being good is high. If offspring is not good, it will be removed in the next iteration during selection, because selection will depend on the fitness value. Now elitism is a method by which we can transfer one or more good chromosome from a population directly to the new population. Okay, before crossover or mutation, we can directly transfer few good solutions to the next population. This is called elitism, and it has been found that elitism significantly improves the performance of genetic algorithm. Now mutation, what is mutation? It is the process by which a string is deliberately changed so as to maintain diversity in the population set. Mutation probability is generally very low, less than 1% it can be. Mutation is applied on the offsprings generated with a very low mutation probability, and the value of the string or the chromosome gets changed randomly. Example of mutation is given here. Suppose this is one offspring and mutation is applied. Out of these all bits, only in these two cases the mutation has happened and the bit has become from 1 to 0 and 1 to 0 again in this case. Now the advantages of GA. Now the advantages of GA is that first of all it is global search method, because genetic algorithm starts with a set of population. Unlike other method, we are starting here with a set of initial solutions, so the chance of traversing into the larger area of the search space is higher. Second, it is blind search method. This means that GA only use the information about objective function. Here we do not require the knowledge of the first derivative or any other auxiliary information. Third point, GA use probabilistic transition rules. This makes them more robust because in each iteration the probabilities gets changed. And finally, GAs can easily used in parallel machines. Definitely this will reduce the overall computational time substantially. Now that's all.